Okay, good. So today, oftentimes I see some of this webinar to be very research oriented, and today I wanted to do maybe a fresh look at what we have on the market and really down to the earth, what's going on with the biochar and the energy market, because there are a lot of different markets, but what about the energy? So do you see the next one? Still working?
Yes, yes.
Okay. So we have a lot of problem on Earth right now. So there's the changing climate. We can see the increase in temperature, which causes a lot of desertification and increased temperature, demand for conditioning air and all those kind of things. We have more industrial demand for energy because we are more people on the planet. And I was looking yesterday, there's 74 million plus people this year only to add to the 7.8 billion people on Earth. So the other thing is that to respond to all this, we need, oftentimes what human does is that we go for deforestation, and which bring more CO2 in the air, which increase climate change and cause a lot of problems for water, temperature, and all those kind of food security. And also we are not quite good at recycling so far. We talk a lot about it. There's a lot of improvement that have been done in the last 50 years, but still have a lot to do. So one of the things that we talk a lot is about biochar to be a solution for some of these problematics, and with laws and regulation for controlling and promoting any action to decrease the climate change. One of the things that biochar is recognized as a green alternative to fossil coal. The other things that we can think about is the biochar can be made from forest residues, and also production of biochar more often than others is that it promotes the reforestation, because if it's made with forest residues, then there has to be forest somewhere. Other people think that we will make energy with biochar by planting forest because of biochar, and others, well, less optimistic would think we will decrease the forest surfaces because we'll cut the trees to make the energy. But so far the tendency is we reforest to make a whole bunch of different products and non-linear products as well that live underneath the trees and all those kind of things. And biochar is only made from the residue of the exploitation of the forest. So it's a good thing. And also the biochar can be made from agricultural, urban, industrial residues, for which oftentimes we don't know what to do with because they are contaminated. Let's say we can have food that is contaminated with soil and vice versa, and so they don't want to use a food to make, I don't know, biomethanization or things like that, because they don't want this contamination. But with pyrolysis we can use this, actually pyrolysis and gasification, we can make a very good biochar that can be used for the energy market if it's not accepted for the agricultural market. So it's kind of an alternative to different ways of recycling and any type of residue that contains a lot of carbon. And we can see more and more that the biochar is a complement. The manufacture of a biochar is a complement of other recycling techniques. So you all know what is biochar in here, I suppose. So here the definition for the energy that's I suggest, but it's not it's not necessarily approved. I just make something easy so that everybody understands. It's a solid containing large amount of carbon and energy that is made from a sustainable transformation of the biomass to replace coal or non-environmentally friendly charcoal. Because oftentimes people say biochar is only charcoal. It could be charcoal, but it's charcoal that is well made when it's made from wood, but it could be made from a lot of other things. And there are other names that we use for biochar, and sometimes it gets confusing for people. You have biocoal, biocharcoal, charcoal, black pellets, and all this kind of vocabulary oftentimes are associated to biochar that are used for a specific sector. Charcoal is often refers to cooking and barbecue. Biocoal often will refer to very high energy content, and black pellets to lower energy contents for the energy sector. So one of the things that we can think of is what type of product do we have to put in the market. Biochar for the energy market, we can see it I can divide it in three large products. You have the black pellets to replace the white pellets. It could be called also torrefied pellets or torrefied granules. And the energy content will be between 20 and 23 megajoule per kilo. It's usually super homogeneous. And it can be used for electricity, and so in power plants or in blast furnaces. The charcoal or oftentimes it's made into briquettes, contain more energy, usually 24 to 32 megajoule per kilo. It's either in a form of large chunks, because it's made with a larger piece of wood, or with briquettes. Briquettes oftentimes they use binders because a biochar may be made with straws or other kind of agricultural or forest or urban residues that is too small, so they have to put it into usable, more easy shape. So briquettes is oftentimes the choice for this type of biochar. It's oftentimes less homogeneous and used mostly for cooking. The biocoal, I refer to biocoal to the 27 to 32 megajoule per kilo. It's homogeneous usually because it's targeted mostly for the metallurgy and other very heavy industry like the concrete and the aluminum industry. So it has to be a super good quality product to replace, for example, the anthracite. So when we talk about black pellets, a lot of people will say, well, why don't you just use white pellets in the power plants? Well, first of all, it's not only used in the power plants. It can be used also for concrete and aluminum and metallurgy. It has when we produce the black pellets, the interesting aspect of it is that since it's mostly torrefied rather than pyrolyzed, it gives a yield of 70 to 80% compared to the initial feedstock based on a dry basis. So the yield is very high and very interesting. The technology also is less costly than for pyrolysis. Something that is interesting when they use the black pellets is that if you switch 10–20%, oftentimes you don't need any modification to your combustion equipment. So you can add the black pellets to decrease your footprint, and it doesn't require much money. But however, if we want to switch to 100% with the black pellets to replace coal, then you need some modification to a power plant, for example, but it's still very limited compared to the business, how much money a power plant will make. And sometimes people will say, well, it's more expensive than the white pellets. But actually, usually people sell the black pellets on an energy basis compared to the white pellets. So for each unit of energy, the black pellets cost the same thing most of the time, but there are more advantage to the black pellets than on a simple switch from the coal to the black pellets, to the renewable energy. First of all, it is weather resistant, which the white pellet is not. White pellet is really sensitive to rain and water. And compared to coal, for example, it has a very low sulfur content. So the black pellets is something for which several countries are going to. When we talk about charcoal and briquettes, then the energy content is higher. Therefore, the yield from the feedstock is lower. It's 20 to 40%. It depends on the technology. The traditional techniques have very low yield, and also they pollute. They let a lot of fume coming out. But the new technologies for manufacturing charcoal and briquettes are very clean. And so if we have to keep in mind that it's important to move the producer from old technique to new technologies, in particular in developing countries, because they're really polluting themselves by making this charcoal as they used to. One of the advantages of the briquette, as I said earlier, is that it's often made with ag and urban residues. So even if you have a low yield, if you get paid or you have a tipping fee or you pay nothing for your feedstock, which often happen with urban residues, then your charcoal can have a very competitive price with the coal, or with some of the charcoal that are made right now in illegal way in developing countries, where they cut the trees during the night, make the charcoal and sell it then. So if you get paid to transform the residues, then you can compete with those people and be super clean. One of the interesting aspects also of this charcoal and briquettes is that it's a slow burning. So when you have some mining transformation oven to keep hot very long time, so it could replace the coal, and it's low sulfur, except if you have a urban residue that may contain high sulfur, but usually it's very low sulfur. And yeah, the demand is there for developing countries, because they still use it for cooking. And actually, in Canada and United States, we are not in developing countries, but barbecue is very fashionable. So the demand for briquette and charcoal is very high right now. When we look at the biocoal, the yield compared with the feedstock that come in, it's between 20 and 40%. So it's kind of low. If you take a feedstock that costs $100 per ton, then your biocoal become a $500 per ton, which make it up just on a basis on the yield plus the technology and the OPEX, the CAPEX, and all those kind of things. So people will say, hey, don't think about biocoal at all, because it's way too expensive compared to coal, where we pay $30-40 per ton. But actually, where the countries where the greenhouse gas emissions is highly regulated, it becomes economically efficient to switch to the biocoal. Because let's say in Canada, they pay $30 per ton per CO2 emission, and we consider there's 3 tons of CO2 emission per ton of coal, then it's $90 per ton. Then right there, plus the transportation and all those kind of things, right there you have $100 increase in your price. And oftentimes what we will do with the biocoal is that they will replace high by some of the biocoal that have the highest cost, like the anthracite, and very specific anthracite, which their price can go up $300 or $400. Then it becomes very efficient to switch to biocoal. The demand increase a lot in those regulated countries like the Northern Europe and Canada, and Japan start also. And so the demand is there, but we have to be sure that the price is still low because it's a commodity. And so oftentimes it's made with residues. It could be urban residues for which you receive a tipping fee so that you keep your price very low. One of the things, however, for biocoal in the mining industry or metallurgy industry is that we often look at chemical reactions. So for some industry, they will not buy a biocoal with very specific contents of specific metals. And it belongs to every single mining industry or metallurgy industry because it depends of the ore, the content of the ore. So oftentimes what we see right now is that the biocoal is made exclusively for a specific company with their very specific specs. So we cannot just make a biocoal and say it's good for everybody. Most of the time we have to adjust the biocoal for the specificity of the industry that will consume it. So as I said, it's oftentimes used for coke breeze or anthracite for the metallurgy. If we use less than 10% of biocoal in the mixture of the energy input, meaning that 90% of the rest may be fossil coal, then there's usually no modification at all to do in the equipment. However, if we want to use 100% biocoal rather than fossil coal, then either we make a biocoal very specific for the equipment and the production, or we have adjustment of the equipment, or both of them. So there's some work to do before selling the biocoal to the metallurgy. Here I thought that maybe you want to see this type of information for the black pellets. The production in North America right now, Canada and United States, I didn't put the Mexico, it's 300,000 tons in 2020. For the projects that have been announced that are under construction, that we could at GECA in our company, we could verify that they are actually under construction, they are the permit and all those kind of things. It's gonna have to be, they are going to produce 2.4 million tons in 2023. And the tendency for all the projects that we can see that are very serious by actual producer under expansion or announce, or kind of project that are very serious, we understand it's gonna be about 4 million tons in 2026. So the demand, but 4 million tons, it seems a lot, but actually it's really not much compared to the consumption of coal right now. There's, for example, a power plant in New Brunswick in Eastern Canada. It's using 1 million tons a year of coal. So 4 million tons altogether in 2026 in North America of biochar, it's not gonna respond to the needs. The demand right now, it's mostly for export, for the black pellets. Export to Europe and in Eastern Asia. There is some local consumption, but the local consumption is very limited, but it's going to increase because the government and the Canadian government, the Northern Europe governments push a lot for energy, renewable energy. I don't know about United States. We see after Trump what's going on, but Trump was not pro renewable energy. We'll see with the new administration what it will do. But so far, it's mostly for export when we talk about the North American production. And demand, we expect the demand to be at least twice the production in 2026. For the biocoal is worth more money than the black pellets. At the same time, it's sold at higher price, but it takes more feedstock to produce. And those that consume the biocoal are a lot of the metallurgy and the mining industry and other companies with smaller boiler or things like that. And so when we did the count, we come out just with about $1 billion as well for in 2026 for the markets. And now it seems weird, but we have only 100,000 tons a year that is produced about that. Announced projects and projects under construction will have 1 million tons in 2023. And we expect 2.5 million tons in 2026. People will say, you're dreaming. No, I'm not. This is actual data. This is data from, we know at GECA Environment, we know every producer in North America, and we are in contact with them. We know who is expanding, what size of the plants they are gonna do. And we are aware of a lot of new projects also coming out and the demand. And we work also with government instances. So it's not, we are not dreaming, it's actual data. And one of the things that's happened, and it will happen more and more and more, is that we see that the biochar will be mixed with the coal, either at the entrance of the oven or will be mixed to make a pellets. So it will be a hybrid pellets. And some people start doing that to switch from coal to biochar to decrease their footprint. And more compared to black pellets, where the consumption is in other countries, the biocoal will be within the same continent as it is produced. So it will move a little bit less, we believe. At least so far, it will move less than the black pellets. Here are a few examples of consumers of this biochar. We have the power station in Finland that has, oops, I can see, sorry, that something's wrong. Lorem ipsum dolor, I don't know what that means. I'm sorry about that. I can see that my texts have disappeared somehow. So they will be producing energy using black pellets. And one of the big champion right now is Japan, is really hungry for the black pellets. It started with white pellets, and the white pellets being too sensitive to weather and to transportation, and it costs less expensive to transport the black pellets, and it's more energy. You need less place for storage and all those kind of advantages. So the Japan are going very strong to the black pellets, and they buy from North America. And then here I just put some very large international companies that we know and we work with, work on biocoal and biocarbon. Vale, ArcelorMittal, and Elkem Metal, all in the metallurgy, on all iron ore. Elkem does a lot more than iron ore as well, but those are companies that will switch, and they announce it out loud, and we can find some articles in on the internet on that switch that they want to do. They are not ready yet, but almost. I mean, they are progressing very, very fast, but they cannot switch too fast until there's enough biocoal production to respond to their needs. So one of the restrictions they have to their switch right now, it's the quantity. There's not enough biocoal for them to switch. So they will start just one plant at a time to switch a part of the coal they consume. And like Elkem Metal will make its own biocoal to respond exactly to the needs it has in the for chemical reaction and those kind of things. This is only to give you a few examples because I took that book. I could have taken other type of mining industry, aluminum, and concrete, and other type of industry that are looking very carefully about consuming either black pellets or biocoal. However, it's fun. I make you dream about this. I tell you, it's a 1 billion market for each of black pellets and biocoal. However, those that are there will fight very strong to stay alive and take larger share of the markets. Biocoal competes directly with the energy from biomass, like white pellets. So some are very well established in some countries, and they will fight to remain there unless we work with them very carefully. Like the white pellets, several of them will produce both white and black pellets, and so they are not gonna compete with each other. But otherwise, it's gonna be difficult to move and to take some part of their share. The other thing is that coal and traditional charcoal, natural gas are very old industries, very well established with a lot of lobbying. So even if the government pushed the industry to switch to renewable products, they have very good lawyers, very good lobbying, and they usually take very good argumentation to ask the government to postpone their implementation. And so far, that's what they have been doing. So it's not easy to displace, mostly when your country is a coal producer. And the government is like in between. Yes, they want renewable, but yet they don't want to lose jobs and the revenues and those kind of things. So it's a very strong competitor. Of course, we can work with them rather than fighting with them. So being their friends by making hybrid products to help them switch to the more renewable industry. The solar, the wind, hydro, and the new nuclear. I call it the new nuclear because they have developed a lot of different products and they are a lot more efficient than they used to. And we can have very small reactors right now, and we don't hear about them too much and we haven't heard about them for the last 30 years. But hydro and nuclear will go very strong because they consider themselves as renewable. So they would fight for their place, they would claim larger share, and they would say that, listen, biochar is not environmentally friendly because they will put trees, they will cut trees because they will put energy crops, and if you cultivate energy crop, you will decrease the accessible land for food. And so this is some of their argumentation, for which the biochar industry, we have to be very intelligent and in responding to that. And also we have to think that although we would like to have the biochar just about everywhere, there are somewhere that it wouldn't work because the industry are used to liquid or to gases, and so the biochar is the solid. It's an advantage when we want to replace coal and anthracite, but it's a disadvantage if we want to remove petroleum, for example, on the liquid aspects. And what do we do with that? There are different actions that we should take to gain share in the energy market. First of all is organization and planning. Everybody, the industry is very young, and it's everybody works on their side, and hey, I have a better technology than you, and I will get the market before you, and all those kind of thing. Actually, when you think about it, a well-established industry like the mining industry, the hydroelectricity, the coal industry, well, although they can be competitors, they actually work hand in hand to organize, to make committee and to do lobbying for their industries. And biochar industry has to do the same. So we have to organize and make association and lobbying for that. We have to work hand in hand with potential consumer. I just name a few that are very influential in the world, but there are a lot. Everybody has some of influential consumer in their country, and they have to work hand in hand with them to be sure that it will respond to their needs at the price they need. And the price is discussing. We have to discuss about price, because when we talk about price for the iron ore industry, for example, you say, hey, I pay $30 per ton, I won't pay $300 per ton. But then when we start digging up a little bit, and well, what other prices do you pay associated to that? When we talk about carbon penalties, transportation, and all those kind of things, and you can understand that you are able to be competitive with some of the higher price coal. And also to be intelligent, I think, and to make it for very renewable product for a very, very, very long time, we have to promote forestation and the use of residues. Forestation, it's completely the opposite of what people would think when they are against biochar, because they think, hey, we will cut the trees to make biochar and a lot of biochar. No, we need to plant and plant and plant. And we will use the residues to make the biochar. And for agricultural aspects, it's the same thing. We won't promote cultivation of energy crop unless it is a very, very poor system where you cannot produce food for whatever reason. It could be contaminated. For example, in the Caribbean, there are some projects of power plants using biochar, but biochar that is produced on contaminated lands. So you cannot put any food on it, and because you cannot produce food, people just let it go like that. So rather than that, we can just reforest and harvest what we can to make wood and whatever other product from the forest, and then with the residues we can make the biochar. The other thing that is very important is we need to develop standards. It's good for biochar in the energy market, but it's good for biochar in all other markets as well. Because people are scared to buy biochar because they are scared to have a good product one day and a bad product the other day. So they need consistency, they need standards, they need to be sure that it will reach their specificity. And we need also to support technology developers to be sure that the technology are very environmentally friendly, because all the environmental aspects, this is what will make the biochar industry survive. And so after we have lobbying, connect all the actors of the chain of the biochar industry, so that the feedstock person can talk with the technology and with a retailer, with a reseller, and all this kind of people. Right now, they all works on their side. And oftentimes the governments, whatever the country, they want to ask questions. They want to have information about the biochar to take decision for laws and regulation and reglementation, but they don't know to who to address the question, because we are not organized. So we have to be organized and tell them, if you have a question, this is the organization that will respond to your needs. And we have to develop market and tools for the consumer. How can I choose a biochar? And what's the standard? And so that the consumers know where to get it, how to get it, and what to get. And of course, we can continue the R&D. That is very important, mostly for the biocoal, for the metallurgy and the mining industry. So in summary, the energy market is still marginal, but it grows exponentially. We can reach different markets through different formats. It's a $2 billion within the next 5 years. So it's a big market. As it grows, there will be more competition for the feedstock, for the agriculture and the urban residues. So we have to talk to each other. We really have to organize each other. And the biochar industry must also make standardization and involve all the players. So thank you very much. And here are my contacts if you want to reach me.
Thank you very much, Suzanne. Very interesting insights into the energy market, or the place for biochar in the energy market. You got some questions in the chat. So Robert asks, do you see the energy applications of char to be an interim measure as we wind down the emissions from power plants? As more and more emission reductions are needed to combat climate change, won't these plants need to be decommissioned? So
yes, actually, it could be a lot of power plants are decommissioned. It depends on the countries, but it could be an intermediate solution by the time that other renewable energy come up. And this transition, we look at it, and some of the transition will be about like 15 to 20 years. So it's gonna take some time to remove the, let's say, the power plant based on coal. And so, and some people are building more, actually, you see in China, in Brazil, and the Caribbean, and other places. So it's probably an intermediate solution for the power plants.
And another question from Robert was, what is the difference between traditional charcoal and the charcoal briquettes used in power applications? So I think biocoal and charcoal briquettes.
Well, oftentimes the charcoal briquettes are, can I say, are addressed to barbecue and cooking. So they are the standards is lower. The homogeneity is less, it's less good. It's more addressed to the residential market than to the industrial market. So there's less restriction on how can I say, on the properties, the specs per se.
So I would assume that biocoal right now is mostly made from wood as a feedstock, or?
From residues of wood. It could be demolition wood. It could be residue from sawmills that are not used, like bark, and those kind of product. Mm-hmm. In North America, in Africa, is often made from agricultural residues.
And another question from Fred. You mentioned biochar made the right way from wood, I assume through torrefication. Do you have any comments about other chars like pyrolysis chars or char as a side product from the production of bio-oil?
Oh, well, actually, it's a very good question, because yeah, there's a pyrolytic oil and bio-oil and all those kind of product. And as I said earlier, I think in the discussion, not everybody was there, is that pyrolysis and making biochar is often a complementary technology to other technology like biomethanization, bioethanol, and those kind of product. And so biochar for the energy market as a side product, as a co-product, let's put it like that, is a very good way to reach the market at lower price. but it still has to respect specs. That's a very good way to do it.
And the last question from William. Recently, a USDA webinar stated that activated carbon is carbon positive. Can you explain how they got to that conclusion?
I don't understand the question. I will try to see, because I don't see the questions.
You can open the chat and then you should see it on the bottom of the screen.
Participant, muet, contrôle à distance, plus. I kind of lost the. I'm sorry, I'm not too good right now. So anyway, I don't understand the question. If
okay.
you have other question.
William just say he will contact you directly. And a last question from myself, because I'm working on sequential uses of biochar. Do you think, or what's your opinion on organic pollutants on carbon materials that are used for as a biocoal, for example? Do you think that's an issue for the industry?
Well, organic material for biocoal, actually once, if you do biocoal, the energy, the volatiles that are left are very, very low. Usually it's not a problem compared to the actual coal.
No, I mean organic pollutants, for example, if you use biochar as a filter material, you sometimes have organic pollutants that you filtered out of water or whatever. And the residue of this is an exhausted filter, which is biochar with adsorbed contaminants. Would that be an issue for the energy industry? Because I would assume that if you burn it, organic pollutants shouldn't make too much of an issue.
I don't think it's too much of an issue for as long as they burn it at higher than 1200 degrees C. Usually there's no organic left. So I don't think it's an issue. So it's a very good point in a sense that people think more and more are using biochar for decontamination, so whatever it is, soil and air and water. And once they are contaminated, then we use it for the energy. So we recycle one more time the carbon into it. And I think that's a very good way. And some of the things that we do actually, that we do have project with that, is decontaminating soil with plants that grow and are extractive, and then making the biochar with that, and then the energy. And we also work on project where organic material is used for bioethanol, and the sludge from the bioethanol is then treated in the pyrolysis plant and end up being a biochar. So we recycle the carbon within it, and with the pyrolysis at higher temperature. And when the biochar has 28 to 32 megajoule per kilo, there's not much left of organic there.
Okay, thank you very much, Suzanne.